particles of mass is 3 kg and 7 kg, 7 kilograms, 3 kilograms, are connected by a light and extensible string that passes over a smooth peg. 3 g is held at ground level, okay, with the string above it taut and vertical. The 7 g is held at a height of 80 centimeters above the ground, okay. So we need to change a few things. So, a few things to note. First of all, we're going to change this 80 centimeters to 0.8 meters because part of our standardized units is that things must be, distance should be in meters. This 3 kg has a weight of 3 g newtons, where g is our 9.81. The 7 kg is going to be 7 g newtons. And then we have tension in the string. So in particular, tension is pulling the 3 kg up, and the tension is also trying to resist against the 7 kg mass. So in other words, if that tension were not holding that 7 kg mass, well, let me start from basics actually. With this, we know that the string is going to go down on the side of the 7 kg because it's heavier than the one of the 3 kg. But so that's why the 7 kg would go down and the 3 kg would go up. But equally, there's that string that is pulling the 3 kg up, because without that string, the 3 kg would not be moving. Equally with the 7 kg, the reason we have the tension pulling it up, you can think about it as the 7 kg wants to move down really fast. And if it didn't have that string, it would move down a lot faster. Does that make sense?
Yeah.
No.
No, yeah, it does.
Oh, it does?
Yeah.
You sure?
Yeah.
Okay. So then we can now form two equations. So before we do that, actually, we need to pick a direction to be positive and negative. For the sake of ease, I'm just going to say it's important to be consistent. So let me ask you the question. Which way would you like to be positive and which way would you like to be negative?
What do you mean?
With physics or with mechanics
Yeah.
rather, when you're looking at vectors, forces and things of that nature, you have to decide on a direction that you're going to take as positive and a direction that you're going to take as negative. Like up forces, down forces, things like that.
Think that I'm confused.
Okay. I'll make the decision and then we'll carry on and hopefully it will make sense. So I'm going to say up is, let's just say up is positive, and let's just say down is negative. It doesn't matter which way around we choose. Okay, so with these connected particle questions, I think a good and easy way to think about it is to separate the systems. If you actually separate the systems into two components, then it makes it much easier to work with. So if I look at the 3 kilogram mass for the moment, the forces I have acting on it are tension, which is going to be positive because we said up is positive, and we've got the 3g, which is acting downwards, so it's minus 3g. By the way, I'm using F equals ma, where F is resultant force. So the resultant force, because the forces acting on it are T and 3g, so T minus 3g is equal to mass, which is 3, because it's 3 kilograms, times acceleration, which I'm just going to call A. And the acceleration is acting upward, so I leave it as A. Okay, now for the other particle, what have I got? Well, I've got the 7g newtons acting on it, which is acting downwards, so that's going to be negative. So minus 7g. And then I've got the tension acting on it, which is acting upwards, so plus T. Again, I'm using F equals ma. So that's the resultant force on the 7g mass. So 7g plus T is equal to mass, which is 7, times acceleration, which in this case is minus a. So if I just tidy that up, I have T minus 7g equals minus 7a. So I've essentially got two equations and two unknowns. I've got T minus 3g equals 3a, and I've also got T minus 7g equals minus 7a. And we just have to solve these simultaneous equations. Because we're asked to show that the magnitude of acceleration is 3.92, I'm going to try and eliminate T. There are so many ways I can go about doing this. I'm just going to do it like this. So equation 1, equation 2. I'm going to do equation 1 minus equation 2. So T minus T is nothing. Minus 3 minus 7 is the same as minus 3 plus 7. So that's 4g equals 3 minus 7 is 3 plus 7, which is 10. So that's 10a. And then 4g over 10 is equal to a. And we can check with our calculators. 4g over 10, where g is 9.8, is going to be equal to 3.92 meters per second squared. Any questions there?
No.
No, I'm all good. Thank you.
No worries. So yeah, the solving of the simultaneous equations, that's the easier bit. The bit that you have to really pay attention to is just the F equals ma stuff. You really want to make sure that you are setting up your system correctly, you're labeling your diagram correctly, you change distances. I mean, the distance bit we didn't need for the first part, but that probably comes in the second part. But at least for this part, you want to make sure that you label everything correctly and that you pick a direction for which your forces act, positive or negative.
You know when you're writing the equation for the F equals ma,
Mm-hmm.
like how do you know when to put which number to put first?
What do you mean? It doesn't matter which one goes first. You can put any. If I've understood your question correctly.
So like, you know when you wrote T minus 3g equals 3a, and then
Yeah.
the other one you put minus 7g plus T equals 7. Oh, it would be the same either way around, right?
Yeah. So for the first one,
yeah.
I put minus 3g plus T if I really wanted to. Yeah.
Oh, okay.
The thing that matters more, it's not so much what comes first, but the more important question is, how do you know which one's minus? And that's where the direction matters. If the force is acting upwards, in this case, it's positive, and if the force is acting downwards, it's negative.
All right. Okay.
Okay.